Hello everyone, welcome to lesson 10 for Calculus AB. This lesson we're going to talk about one of the most important rules for derivatives, the chain rule. We've talked already about the product rule, the power rule, and the quotient rule. I will be honest with you guys, I think that the chain rule is used more, I don't think I know. I know that the chain rule is used more often in calculus than any other derivative rule. So let's go ahead and get started with what we need to do. So what we're going to do first, I think this is always interesting how we teach this at the very beginning, is we're going to go ahead and we're going to show you guys how to do this problem using the power rule, and then we're going to simplify this expression and actually find it using the power rule again, and you're going to see that there's a difference in these two answers. So there's one extra step that we must do, which would end up being the chain rule. So if that didn't make any sense, hopefully this will make sense when I talk about it right here. So I'm going to go ahead and find the derivative of this. And so what we're going to do with this problem is notice that we do have a function raised to an exponent, right? So we've learned in the power rule that we can move the exponent down and then multiply this number by this, and we're going to get 2 times 1 is 2. And then we're going to leave everything inside the parentheses alone, just like we leave our x alone, right? We'll find the derivative of 5x cubed. We move the 3 down, we leave x alone, and we subtract 1 from the power, and that's exactly what we get right here. So then when we simplify this, we're going to get 6x minus 10. So using the power rule, we get that this derivative is 6x minus 10. Well, let's look at it in this way. Let's go ahead and algebraically simplify this first by foiling, and we're going to get 9x squared, and then we're going to multiply and we're going to double, and then we're going to square the last. Now let's go ahead and use the power rule again on this expression and then compare the two results. So we do y prime, we're going to get 9 times 2, which is 18, 18x. The derivative of negative 30x is just negative 30, and then the derivative of 25 is just 0. So this is the correct answer for this problem. So what do we notice over here? Well, what's lacking over here? Well, how do I get this equal to that? So how do I get 6x minus 10 equal to 18x minus 30? And so hopefully you guys are realizing, oh right, all I have to do is multiply this value right here by 3. And that's absolutely correct. Why 3? Is it always 3? No, it's not. Well, why? Well, what we have to do here is we have to then take in account that whatever our expression is that is inside of our parentheses, we have to also multiply by the derivative of that. So if I give you the function y equals 3x minus 5, I also got to figure out, well, what's the derivative of that? And that's 3. So that's the chain rule, is that when you have some expression raised to an exponent, whenever you move the exponent down, you leave everything inside the parentheses alone to 1 less power, and then you have to multiply by the derivative of that exponent. Okay, so then we asked the question, why were they different? What did you notice about the answers? So obviously we realized that we need to multiply this expression by 3 to get our answer here. So we need the chain rule, right? We need to employ the chain rule. And that's exactly what we will do for the rest of the problems. So everything that we've done so far, ladies and gentlemen, has just been where our derivative has been 1. So that's why we haven't noticed that our answers are a little bit wrong. So the formal definition for the chain rule is if you have a function that's got a composition of 2 or more functions, all right? So we have some function inside of another function. What this really says is if you're taking the derivative, you take the derivative of the outside function first, leaving everything else inside the parentheses alone, and then you're going to multiply by the derivative of that middle function. And that's exactly what we did here. We really have the function, and actually down here we can talk about it. We can look at it right here. So we really have the function f of x and the function g of x minus 5. If you guys remember compositions, then f of g of x is going to be equal to, well, you take all of g and you throw it into f, then you're going to get 3x minus 5 squared. And that's exactly the question that we started with right here at the top. So what we can do here is we can take the derivative of f with respect of g in it, okay, so just f, and then we're going to multiply by the derivative of g, and this is what the chain rule says. So what's upon the derivative of f? Well, the derivative of f simply is just 2x. Well, if I want to then substitute in g of x into x, I can go ahead and do so and say 2, and then where I see an x, I replace that with 3x minus 5, and that's exactly what I do here. And then I'm going to go ahead independently and take the derivative of this function, right? This is our inside function, 3x minus 5, which is 3. And remember that all I want to do to find this derivative is just actually multiply what we have here by this. So 2 times 3x minus 5 times 3, and that's going to give us, again, 6x minus 10 times 3, which will give us the final answer that we had at the very top. Okay, so that's a way of looking at the problem. But let's actually look at it and maybe do it maybe a little more simple way. This is the background of what you have to do with the problem, but let's look at a couple of examples and show you that this is the way I think about doing the problem. So it says find the derivative of v of x where we have the square root of 4 minus x squared. Well, v of x, I'm going to go ahead and rewrite that as 4 minus x squared raised to 1/2 power. So we have a function inside of a function. So we have the square root of x, that's our major function, and we have 4 minus x squared, which is our inside function. Guys, here's how I do the problem. Here's what I think about. And you're going to hear me say this all the time in class. So I go ahead and I take the exponent down, and you multiply it by what's in front of the parentheses, which in this case is 1. So I do 1/2, and then you're going to hear me say this a lot. You leave everything inside the parentheses alone. You do not touch it. It's sacred right now. Can't touch it. Great. To 1 less power. Once you have done that, you've actually taken the derivative of f with g still inside of it. And then, guys, all you have to do now is your eyes focus to what's inside the parentheses, and we're going to multiply by the derivative of this. Well, the derivative of 4 is 0. The derivative of negative x squared is going to be negative 2x, and then we're good to go. Once we do that, we do not need to simplify more. Students always say, now can we multiply by negative 2? No, there's no exponent here. It's just this function times the derivative of this. Do not simplify down more than that. And then we're going to go ahead and start simplifying. The 2's are going to cancel out. And so what we're left with here, f prime of x, well, what's on the top is going to be x, a negative x actually, so negative x on the top. And then the bottom, it's going to be the square root of 4 minus x squared. So this is, ladies and gentlemen, the derivative to that problem. And that's all that you have to do. All right, so let's do this next example. And I encourage you guys to pause the video if you need to and see if you can do it, before I can, and then, play the video and see if you get the answer right. Okay, so let's go ahead and talk about it. So again, I've already got it nicely written for me, so I can go ahead and just say y prime, move the exponent down and multiply it again by the leading coefficient. But again, the leading coefficient is 1, so 3/2 times 1. And then leave everything inside the parentheses alone. You're going to get so sick of me saying that, but leave everything inside the parentheses alone to the 1 less power, right? And then, ladies and gentlemen, our focus is going to be on this. I don't care about anything else right now. I don't want to subtract another power. It's just this. Our eyes just go to this. So I'm going to multiply by the derivative of x squared plus 1. Well, the derivative of x squared is just 2x. The derivative of 1 is just 0. So again, we luckily have our 2's cancel out. And so y prime is going to be equal to, and notice that everything is on the top, right? There's no negative exponent here. So we have a 3, we have an x, and then we have the square root of x squared plus 1. And yes, you could leave it if you wanted to, 3x and then x squared plus 1 to the 1/2 power. And they're both acceptable answers. And that's the chain rule, ladies and gentlemen. That's the chain rule. It's very powerful, all right? Very powerful stuff. So a couple more pretty basic chain rule questions just to quickly go through here would be example number 1 here, where it says h of x equals 2x plus 1 to the 10th power. Now what you guys were taught before is that we have a 2 here. We can easily just foil this and then do the power rule. A 3 also would be fine. I think we could probably cube this pretty easily and then distribute. But we don't want to do this to the 10th power. So the chain rule makes our lives much easier because we can pull the 10 down. We can leave what's inside the parentheses alone. Again, leave what's inside the parentheses alone. You're going to get sick of me hearing it, so I keep saying it over and over and over again, to the 1 less power, and then you're going to multiply again by what's inside of the parentheses, and the answer would just, the derivative would just be 2. So your final answer will be 20 times 2x plus 1 to the 9th power. Don't simplify, you're good to go. Perfect answer. Okay? Then let's look at question number 3, because 2 is pretty straightforward. Question number 3. Let's look at this one. So for this problem, ladies and gentlemen, we have to use the quotient rule. Okay. There are students that sometimes like, well, what if we do this Like what if we brought it up and do this and use the product rule? And you absolutely can. I'm not going to say you don't have to, but I'm not a big fan of constantly using negative exponents into the entire thing. So yes, this is absolutely a way to do the problem. And as a matter of fact, we're going to do that in example number 4. So you guys can do that, but just remember that if you try to do it this way, it gets very messy and you have to use the product rule. So it's just, easier, I think, to just work and use the quotient rule here. Okay, so let's actually use the quotient rule. So h prime of x is going to be equal to, so your denominator, we should be really good about that right now, multiplied by the derivative of your numerator, minus your numerator. And now, ladies and gentlemen, here's where the chain rule comes in. So I'm going to change colors here. So now we want the derivative of our denominator. So it's going to be 2. And then we're going to, again, because we're writing the 2 down, right, in front of the parentheses. So 2 times 1 is 2. Leave everything inside the parentheses alone to the 1 less power. And then we're going to multiply by the derivative of this function, which is also going to be 2, right? So it's just a lot of things that we need to take into account when we're doing this problem. And then we're going to go ahead and then take our denominator and we're going to square it. We're going to square it. So it's going to be x squared, or 2x minus 1 squared. And then we can start simplifying, and I'm going to just go ahead and start writing more work down here for this one. So we can start simplifying a little bit, and notice that what I'm going to do is I'm going to pull out a 2x minus 1 in the top. Both of these functions have a 2x minus 1, because multiple choice questions sometimes always have, it's simplified as much as possible. So in the first term, I'm still left with a 2x minus 1. And then, so I can get rid of this little guy right here. And then in this one right here, I'm going to go ahead and get rid of the 2x minus 1 already because it's right there. So I'm left with a minus 4x. And then I'm going to be all over 2x minus 1 to the 4th. And then, ladies and gentlemen, we can finally finish this question up by canceling this with this. And so our answer is going to be negative 2x minus 1 all over, oh, this should be a 2 or 3, 2x minus 1 cubed. Okay, so this is a good way of using the quotient rule and the chain rule to solve the problem. Never ever simplify the bottom. Sometimes it will cancel out. Most times just leave it be. You can leave it be. All right, so let's look at example number 4 right now and look at this one. And again, ladies and gentlemen, the quotient rule is totally fine. You can use the quotient rule for it. I'm going to go ahead and I'm going to rewrite it as, and the reason why I'm rewriting it and why I'm not doing it like I did number 3 is because we have an x here. If I go ahead and rewrite this as x squared plus 4 to the negative 1/2, this is just one function. I just have to imply the chain rule. I don't have to do anything with the quotient rule, the product rule. It's just the chain rule. So that's why I can do that. So again, choose what is more comfortable for you, what you think is the best method to do the problem. Because if I do this, I'm going to go ahead and move the negative 1/2 down. I'm going to again leave everything inside the parentheses alone to the 1 less power. And then I'm going to multiply by the derivative inside the parentheses. I'm going to multiply the derivative of 2x. And so that's really easier, I think, than the quotient rule. The 2's are going to cancel out. And then I'm left with, in the numerator, a negative x. Right, a negative x. And in the bottom, I'm just left with x squared plus 4 to the 3/2 power. Okay? So again, if I have an x here, like we did with here, we would have to use the product rule. And you guys can do that, but you're going to have a lot of negative exponents that you have to deal with. And so I just think this is much nicer because everything is positive here. But again, kind of work the problem out, see what you think, and see what makes you more comfortable. All right? Okay, so the last question is going to be example number 5, and I feel like I can just put it right here for us. So this one we're going to use the product rule. We have a function squared times another function. Now, yes, ladies and gentlemen, you could absolutely square this, and then you could, distribute this to this, and then do the power rule. But let's just go ahead and use the product rule, chain rule. And again, it doesn't matter which one's the right way. It's whatever you feel the most comfortable with and what's going on. But I like to use the product rule here, so I'm going to do the first. So I'm just going to leave everything alone. And I'm going to multiply by the second. And that's why I really like this, because it's just 8. It's just 8. So it's the first times the derivative of the second. And I can't really simplify that. 8's just going to go in the front, and we're good to go. And it's going to be plus the second, and then times the derivative of the first. Well, again, we have to employ the chain rule here. So I'll change the color up for us. So I'm going to employ the chain rule. So I'm going to move the 2 down. I'm going to leave everything inside the parentheses alone to the 1 less power. And I'm going to multiply by our derivative inside our parentheses, which is going to be 2x. right? 2x. And then, yeah, you can try to start simplifying this a little bit. I mean, it's not really that important to simplify, too much here. So h prime of x. I notice that I have, I've got 4 I can pull out and an x squared plus 3. All right, I'm thinking that's initially what my thoughts are here. And then I have a 2 left here, and then another x squared plus 3. And then I've canceled that out, I've canceled that out, I've canceled this out. So I'm left with an x times x 8x minus 1. And that we're going to leave it right there. Yeah, you can now simplify this a little bit more, but this is pretty good. Usually these questions don't get too crazy with simplifying, so I think that's going to be good for us right there. Okay, so that's the first part of the chain rule. The second video I'm going to do is going to talk about the derivative with trig functions using the chain rule. And then maybe the last video, we'll just look at extra practice problems. So I hope that's helpful, and I'll see you guys in the next video.